Okay, welcome to trig graphing with horizontal and phase shifts. But before we start doing that, I'd like to do a problem with you, and then we'll talk about phase shifts and horizontal shifts. First of all, we want to know what this graph looks like. We want to describe in words and sketch the graph of this function. Well, first of all, one of the ways to help describe this is to stack and rack and figure out what's going on. So the first thing I look at is I see that I have a midline of 600. So whatever this graph is, it's cosine. It's cosine, and it's been shifted up 600 so that it's in the mid. That's the midline. Okay, so I know what it looks like kind of. So I'm going to say my midline is, we'll put equal signs here, y equals 600. Now, if the amplitude, because here's my amplitude right here, here's my amplitude. If my amplitude is 300, that means the highest this graph is going to go is way up to 900. And this is important to know this, because when you want to set your window for your graph to look at it, you can tell what the window is. So you know the highest this is going to be is 900. My frequency is whatever's in front of my variable. In this case, it's in front of t, so it's 0.2 pi. And my period is 2 pi over my frequency, or 2 pi over 0.2 pi, and the pi's will cancel out, and 2 divided by 0.2 is 10. Okay, so actually, before we even do anything with this, we can kind of sketch what this looks like. So I'm going to sketch this, and remember, a sketch has to be good, and I'm going to use just quadrant 1, and this is my t-axis because that's my variable, and this is y. Okay, so now I look at it. I know what it looks like cosine. So cosine starts high, so I know it's going to start at 900. Okay, and then I know what the graph of cosine looks like. So here's 600, and then we'll do 300. So if my amplitude's 300, I'm going to start at 900 because cosine starts high. I'm going to come down, see how it works. Now, the one thing is sometimes doing your horizontal axis, but here they made it easy. The period's 10, so I'm going to do 5 and 10, so we can just look at one curve. So it takes me 10 to see the entire thing. So if it looks like cosine, I know the lowest it's going to be halfway is going to be 300. The highest is beginning, and at 10 it's going to go back up to the high point. So this graph is going to look kind of like this. I hope yours is better. And I always draw my midline here just to make sure that it looks like it's the middle way. So here's y equals 600. So this is what this graph looks like. And if you do this and stack and rack, it makes it easy. Now, I do have this picture actually graphed. And you'll see I've done it twice, but it's basically the same thing. There's my amplitude, my midline, and it shows it did 10 and then 20. So I showed you two curves. Okay? Now let's get into talking about phase shift and horizontal shift. And we've already been doing shifting because we just shifted that graph up 600, vertical shifts. But horizontal shifts are shifts that go to the right and left. Remember, they go on the x-axis. And remember how we did this when we did transformation, is that they were inside changes, and they were always opposite of what you think. So if it was a negative on the inside, it'd go to the right, and positive would go to the left. So this you're familiar with. Phase shift is a little bit different, so I'm going to show you the difference. But first of all, let's look at this basic form. Now, if you see it set up like this, and I picked a sine and a cosine graph, A stands for amplitude, so this is our amplitude. The B is our frequency. Okay, M is your midline. Okay, so there's your midline. Now, do you see inside that I have a change? Now, besides being opposite, I want you to notice something, that the frequency is factored out from here. So if this is in factored form, that's the horizontal shift. So if I factor this, H is the horizontal shift in the opposite way that you think. Okay? One thing I want you to make sure that this is in factored form. When I say that, that means my frequency has been factored out and there's another parentheses on the inside. Now if you'll see this thing called BH is the phase shift, which means that if I would multiply this here, I would have BT minus BH. And so sometimes you see it like this. If it's like that and the frequency is not factored out, see how it's multiplied through, then the BH is considered the phase shift. What the phase shift is it basically calculates the fraction of a full period that the curve has shifted. Okay, now I'm going to show you some examples so that you know. So just write this down for now and I'm going to explain it to you. Okay? So let's look at the next page here. And the next page I have this nice little sine curve. Okay? So I have stacked and racked everything here, so we're going to just go through all this. So when I do this, I see that my midline is right smack in the middle is y equals 0, so I'm going to make equal signs there. My amplitude is my high minus my midline, so that's 1 minus 0 or 1. My frequency I can't tell, but my period, it takes 12 to see this entire sine graph, which equals 2 pi over my frequency. Flip their places, 2 pi over 12, so my frequency is pi over 6. So basically this formula here, and they're using a t here, so it's going to be, that's our variable, y equals the sine of pi over 6, t plus 0. Okay? So now we're going to take this sine curve and we're going to shift it to the right. So if you notice, it's shifted over to the right 2. Okay, so now I'm starting at 2. So if it shifts to the right, it's opposite and it's an inside change. So basically on the inside here, I'm going to write it this way. Y equals sine, okay, and you do the first parentheses and you do pi over 6, and then when we want to show it shifting to the right, we have to subtract. So we're going to say t minus 2. Okay, now I want you to notice something. Do you see how this is in factored form? This is still my frequency, and this shows me that my, right here, my shift or my horizontal shift was 2 to the right because it's opposite. Okay, so it's 2 to the right. Now, watch what happens when I multiply that out. So I could write this also as y equals sine pi over 6t minus, so I've multiplied it here, and then I'm going to multiply here. So when I multiply it by 2, I get minus pi over 3. Now, when it's like this, what we look here is this is called my phase shift is a positive pi over 3 because it's the opposite way. Still, it's an inside shift, but it's positive. Now, I want you to see something. See how this is pi over 3 and this is a 2. If it's factored out, the horizontal shift to the right was 2. And as I see the graph, you're like, okay, then you say, well, why do I need to know the phase shift? Well, the phase shift kind of tells you, once you figure this out, how much of the total 2 pi was, what part of the period was it shifted. So if you take this pi over 3, okay, divide it by 2 pi, because that's what phase shift tells you. When I do that, I end up getting 1/6. So basically, this graph has been shifted 1/6 of a full period. Which makes sense if you shift over 2 out of 12, 2 divided by 12 is 1/6. But this is what a phase shift tells you. Now, scientists need to know phase shift, and you will probably use this sometime. This course focuses more on the horizontal shift, so I know you know how to graph it. But the phase shift is important. So to fill this out here, our horizontal shift, okay, even though it's t minus 2, for this graph over here is going to be a positive 2. Okay, and the phase shift is going to be a positive pi over 3. Alright, so this one again is when it's your frequency is factored out, and this one when it's multiplied through. Now I'm going to have you do both in this course because I want you to know how to find them both. But like I said, we will probably focus more on horizontal shifts because I want to make sure you know how to graph. Okay? All right, let's look at the next one. Find the horizontal and phase shift of this one. So we have our curve here, and it's the black curve we're looking at. So we're going to look at this black curve here. Now we're just going to look at this curve to here. Now the only thing about this graph, and I'm graphing it terrible, but we're looking at this black one here, so let's see if I can follow it pretty decent. Okay, is we're looking at that is our original graph. Okay, and it's been shifted over, and if you'll see, it's been shifted over in this blue pi over 12. So let me show you how you work this. So the first thing I'm going to do is do my stacking, racking, and filling out. So we got our midline here. Our midline's right in the middle, so I can say equals y equals 0. Amplitude, it goes up to 1 because here's a negative 1. Frequency, I can't tell you yet, but my period is how long does it take me to see the whole thing. And if you go over here, it's kind of hard to see because of how this graph is, but it kind of stops in here. So you're going to have to take my word for this because it's not really as clear as I'd like it. But the period is actually 2 pi over 3. Okay, so just take my word for it. I promise you I'll give you something more clear in class. All right. So that means the frequency, well, this equals 2 pi over my frequency. So if I cross multiply, I end up getting my frequency is going to be 3. Now, we're not going to do the horizontal shift and the phase shift right yet. So I want to show you how we're going to come up with it, though, and I'll show you how we'll come up with this new formula. The first thing is if I shift this over pi over 12. So let's come up with the first formula here. So I've got, well, let's see now, g of t is the new one. So we'll call it h of t as our first one then. So this is our original, which is the black line. We're going to say h of t is, and it looks like cosine, is going to be 1 times the cosine, so, because that's our amplitude, of, and the frequency is 3, t, and plus 0. So that's our original function that we basically have. H of t is cosine. Now, when I shift it, so this is the blue line, this is what you kind of go through to come up with that. So the first thing I say, okay, we came up with g of t. If I shifted it to the right, pi over 12, that's our horizontal shift. So it's going to be opposite. So inside, it's going to be, the phase shift is a positive pi over 12, but you got to make sure that when you put this in here, this is an equal sign, that you got to make it negative. All right, so I'm going to say equals. Now I'm going to shift this. Now when you shift it, please leave the the frequency out, and we're going to do t minus pi over 12 because I shifted it to the right, so it's negative. So now I see my horizontal shift. There it is. It's got shifted to the right, and that's what we're looking at, blue. Now watch when I multiply this through, and you're going to see where this comes from. So if I said g of t equals the cosine of 3t minus, and if I multiply that by, it's 3 pi over 12 or pi over 4. Now, that means my phase shift is a positive pi over 4, which means if I wanted to know what that was, if I took the pi over 4, because that's my phase shift, divide it by 2 pi to see what part of the whole curve got shifted, pi over 4 divided by 2 pi is 1/8 of a full period. So this graph shifted over 1/8 of its whole period to the right. So this is what phase shift tells me. This is what horizontal shift tells me. So I think I have this down here for you. In most physical applications, the quantity pi over 4 is known as the phase shift and is more important than the horizontal shift. Now this is for scientists. The phase shift enables us to calculate the fraction of a full period that the curve has been shifted. Again, this is used for scientists. It's very important. They use it all the time. But for graphing purposes, I want you to factor it out and use the horizontal shift. And there, I wrote it there so you could see. Okay? So let's do like a little summary on this next slide. So I try to summarize it because it kind of gets confusing. The amplitude is high minus midline. Your frequency is the number of cycles completed. How many do you see? The period is 2 pi over your frequency, and I put an absolute value sign. My midline is y equals k, or high plus low divided by 2, and h is a horizontal shift. Again, remember, b times h is the phase shift. And if you want to know what part of the period that is, you take that BH and divide it by 2 pi. Will tell you the part of the total period that it's shifted. What part of the curve shifted? Okay? So then you have it all on one slide. Now I want to find a formula here that's been shifted but not horizontally. And we're starting to get into word problems now so that you guys can look at stuff like this and be able to come up with an equation. And that's what we're going to practice some today in class, is of an equation that actually means something in the real world. So I have the temperature T in degrees Celsius of the surface of water in a pond. Get it? Varies according to this graph. If T is the number of hours since sunrise at 6 a.m., find a formula for T equals F of T. And this should be capitalized. So T is in Celsius, which is temperature, and the little t is in hours. Okay? So the first thing is, it looks like it starts at 6 a.m. The temperature at 6 a.m., right here, is this many degrees Celsius, and then it looks like it's heating up, and then it's cooling back down after day, and it gets back. So it looks like that's what we're working with. So the first thing I want to look at is, what curve does this look like? And it looks like an inverted cosine, so we're going to call this negative cosine. Okay. Now the midline is important, so I take the high plus the low, and the high is, let's look at this, 23. Sorry guys, I don't know where that came from. It keeps coming up. So I'm going to take the high, which is 23, plus the low, and the low is going to be, looks like 17, and divide it by 2. And when I do, I get y equals 20. So let's draw this and see if this does look like the center. And it does. There's y equals 20. Okay? Now I can come up and do my amplitude. My amplitude is high minus my midline, so it's 23 minus 20, or 3. My frequency, we're going to have to wait. My period, how long does it take me to see this? Well, 24 hours, because it looks like it's happening in one day. So my period is 24 hours, which equals 2 pi over my frequency. Flip their places. 2 pi over 24 is pi over 12. So we can actually come up with a formula here. So we have the temperature, okay, and it's based on the hours. It's going to be -3, because remember you have to put the inverted there, cosine. Pi over 12, that's my frequency, little t, plus 20. And there's no shift here, so we don't have to worry about it shifting. It looks just like that on the graph. Right? So you can take something that's real life and do that. Alright? Let's practice one more and then we'll call it good. Another word problem. Alright, so we want to look at some rabbits here, rabbit population, in a national park, and it falls each year. It rises and falls each year. It is at a minimum of 5,000 rabbits in January, and by July, as the weather warms up and the food grows more abundant, the population triples in size. Use a trigonometric function to find a possible formula for r equals f of t. So let's first draw a kind of a picture, and life is in quadrant 1, so I'm going to make this big enough so we can see what's going on. So they said r equals f of t. So this is the number of rabbits. So we're going to call this r right here. So it's the number of rabbits. And we're going to do time here. And the time isn't, looks like it's in months because they said January. Okay, so they're talking months. So right here, we're going to call this January, right on the y-axis. And then the middle of the year is what? July, and then we're going to come back down to January the next year. So here's our months. We're going to look at the whole year here. And they said it's at a minimum of 5,000 rabbits in January. So we'll put 5,000 right here. And then it triples in size, so it goes up to 15,000. So we'll call that up here 15,000 rabbits. And that happens in July because there's a lot of food. So right here's our rabbits here, here, and then it comes back down in January down to 5,000. And they said, usually they'll say it's a find a trigonometric function, or it's sinusoidal, which means it's a trig function. It repeats and repeats. So I hope I draw this nice. So this is kind of like what our curve looks like. So we want to come up with a formula. First thing we're going to say is looks like amplitude, frequency, period, and midline. Now I'm not going to put phase shift or horizontal shift because our graph doesn't have one, so we don't have to worry about it. So the midline. So when I do the midline, it is high, which is 15,000, plus low, which is 5,000, divided by 2. So that comes out to be y equals 10,000. So that's our midway. So 10,000 would be about right here. So there's our midline. Okay. Amplitude is high minus a midline, so we got 15,000 minus 10,000 equals 5,000. Frequency we don't know yet. Period, it took us 24 months to see this, or excuse me, 12 months, which is a whole year. So it's 12 equals 2 pi over my frequency. Flip their places, so it's pi over 6 is our frequency. So now I have a equation for my rabbits. So I can say the rabbit population is, oh, what does this look like? It looks like a negative cosine because it's starting low. Alright, that's important. Sorry, I didn't mean to skip that. So now when I go to do this, I have the number of rabbits equals negative 5,000 cosine frequency pi over 6 t plus 10,000. Okay, so now there's your equation. Another way you might see it written, because sometimes when you have an inverted curve like this, you'll see them right, the midline right in front. 10,000 minus 5,000 cosine pi over 6t. Okay, well that concludes that. I just have one more picture to show you because I actually graphed this, and I did a couple years. So you see 1 year and 2 years, and that's what our graph would look like. So we did well. And this shouldn't be hours, by the way. This should be months. My fault. Okay? Alright, well that takes care of that. I will see you in class.